Dear students, in our previous class, we have discussed about the operations of stack. So the operations we have discussed are stack, push, pop, peek, peek, then is empty, and so on. Okay, and size. Like these type of operations, and regarding these operations, we have discussed in our previous class. But in our today's class, we are going to discuss about the applications of stack. This means the uses of stack. Okay, in which are all the ways the stack can be used. Just like everything is having its own uses, its own applications. The same way here, stack is also having some uses, but stack is majorly used in many fields. So now we shall see in which are the fields and where the stack is used in maximum. Okay, come we shall see the applications of stack. The first application is the simplest application of a stack is to reverse a word. To reverse a word. You push a given word to stack letter by letter. Letter by letter. And then pop items from the stack. Listen here, students. The first application, that is the first use of a stack, is to reverse a word. Okay, I will take one example here. See, this is a stack. Okay, I had shown you stack vertically. Okay, now I am using horizontal stack. Okay, and I will take one word as computer. Okay, we will take an example, a word computer. Okay, and also I will take a stack. Okay, take stack like this. Okay, if you want to insert this word into the stack, okay, at this time what you have to do, okay, look, I will write that example here so that you can understand it clearly. Test it. So this can be taken as a stack. Okay, I take a word computer. Okay, computer. Okay, how many letters it's having? 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. Okay. 1, 2, 3, 4, 5, 6, 7, okay, and left is 8. Now, the simplest application, the first application of stack is to reverse a word. We have to reverse this word. You push a given word to stack letter by letter. Okay, this word we have to do. First, you need to remember two things. One is push, the another one is pop. Push means to insert items or elements into the stack is called as push. Pop means to fetch the items out or to bring the items out from the stack is called as popping. Okay. Now we want to push a given word into the stack letter by letter. Okay. How we have to put? First we will insert R. Okay. Then we will insert E. Okay. Then we'll insert T. After that U. Then P. Then M. Then O. Then C. Okay, like this we have inserted. What it is saying, reverse a word means we are reversing a word. Reversing means first we have entered in reverse order, just RETUP, okay, MOC. Like that we have inserted a word into the stack, or we have pushed a word letter by letter into the stack, and then pop items from the stack. If you want to pop items from the stack, it means to remove items from the stack. What we have to do, we cannot able to remove R at first. Okay, I will give you an example in one more way. Here, what it is saying, reverse a word. Okay, remember this, reverse a word. So take an example, the same computer. Okay, now we will start to insert a word computer into the stack. First we will insert C. Okay, first C, then O. Okay, then M, then P, then U, then T, then E, finally at last R. Okay, we have inserted. Okay, we will start in while writing also. We used to start from C itself. We will write like this: COMPUTER. Okay, we will not write in reverse order. Okay, so we have inserted a first C, then O, then MPUTER, like that we have inserted. Okay, this is means pushing the given item into the stack. Letter by letter we have pushed. Now we want to pop the items from the stack. It means we have to take the items out from the stack or to remove the items from the stack. Okay, this end is a top end. Okay, and this is the base, because this end is open and this is closed end, so it is stack. Okay, here what we have to do, if we want to remove the items from the stack, then we cannot able to remove C at first. Why? Because it is stack, the base is closed here, so we have to remove R at first. See, R. Okay, R is removed. Okay, then remove E. E has removed. Then after that, remove T. Then T is also removed. Then after that, remove U. Okay, U is also removed. Then remove P. P is removed from the stack. Okay, then remove M. M is removed from the stack. Then remove O. O is removed from the stack. Then finally, C is left. At last, we can remove C. Like this, a word can be reversed by using stack. Okay, we have inserted computer in orderly we have inserted, but while removing, we have removed that word computer in reverse order. This is the first application of the stack. That means if you want to reverse the given word, okay, for that application, it means for that use, to reversing a word, we need to use the stack here. Hope you have understood. This means reversing a word. We will insert a word in right order, but while bringing out, we cannot remove in right order, but in reverse order, we will remove the word from the stack. For reversing a word, we will use the stack. This is the first application of the stack. Come, we shall see the next application, second application, what it will show. The second application here is, this is undo. Okay. Another application is an undo mechanism. Undo mechanism in text editor. In text editor. This operation is accomplished by keeping all text changes in a stack. Okay. Undo mechanism. You need to understand this. Text editor means it is a type of software. Okay. Don't keep in mind the undo is done only in text editor. No. In many softwares, the undo operation, the undo mechanism will work. Okay. What this operation will do, this operation is accomplished by keeping all the text changes in a stack. Whatever we will do changes, all those things are kept in a stack. It means, for example, if you open Notepad, okay, or Microsoft Word, first what you will do, you will type computer. First you will type computer in Notepad. Okay. Then at next what you will do, next you will type below as science. Below as science you will write. After some time, what you will do, you will erase these two things. You will erase two things in Notepad. But again, you want computer and science, both the words. So at that time, what you will do, you will use the undo operation. Okay, click on edit menu. Menu options are given. Okay, file, edit. Okay, edit, view, like this operations are given in Notepad. If you click on edit menu, you will get an operation called undo and redo. Undo and redo, two options you will get. Okay. If you click on undo operation, okay, then again you will get the complete word computer at a time in Notepad. No need to type again and again. Okay. Then again, if you click on undo, then science will going to be printed on your Notepad. Okay, at a time, within no time, it will, the complete word will going to be printed. Basically, undo means the things which we have done previously, we can repeat the same things again and again. That is called as undo. Or in other words, the things which we have, or the operations which we have done previously, If we want to go back to the same operation at the time, the undo mechanism will work. By using the undo operation or the undo function, we can go back to the previous operations. This is called as undo mechanism. So for this undo mechanism, the things which we have done previously, those things are needed to be kept somewhere. So all those things are kept in a stack. Okay, remember how these things are kept, how we can think that these things are kept in a stack, because first we will type computer, okay, then we will type science, okay, after that we will erase both the things. Okay, remember first thing is computer, second thing is science. Okay, if you do undo operation, then at the time what will happen means, first it will print computer, sorry, first it will print science below here. Why? The second item is science, first item is computer. Again, if you click on undo, this will print computer. It means going back. First inserted this, then second we have typed science, then erase. After that, if you click on undo, first science will get print on your screen, then computer will get print on your screen. It means first item which is inserted into the stack is computer, the next item which is inserted into the stack is science. But while popping, okay, these things are, the text changes are stored in a stack. Okay, keeping all the text changes in a stack, they are kept in stack. If you do undo, then first the last element science is printed, then the first element computer is printed. It means the undo things which are we have done previously, those things are kept in a stack. And before shutting down that application, it may be text editor or maybe notepad or maybe Microsoft Word, before closing these things, okay, we can able to perform the previous operations again one by one by using undo mechanism. So for that thing, the previous operations, all the operations are stored under stack. For this process, stack is used. Then come to the third application. What is the third application here? The third application here is backtracking. Backtracking. Okay. What is the actual meaning of backtracking? What is meant by backtracking? I will show you one with one example. Okay. This is a frame or maze. Okay. It is having some route. Okay. To reach an item. Okay. It is having some route. One route will be like this. Okay. From some dimensions or from some of the rotations, finally you will reach to this item. Okay, or if you move with the same thing, okay, then one more thing is there, one more route is there which will be going to cut at some places. Like this it will break down. Okay, like this the routes may be off. This is called as labyrinth. Labyrinth. In backtracking, stack is used. Okay, what actually means backtracking here? Think this labyrinth. A person, okay, he want to reach his item. Then what he will do? First he will start from this route only. Then after moving, he will go to this route. Then he will come down. Then he will follow here. Okay. Then finally, what will happen here means, by following this route, he will come and stop in this position. Okay, see, he will move directly, taking this, by taking this route, he will come here, then he will come to its end, And finally, from here, he is not finding any route to reach the item. Then at the time, what he will do? Again, he has to go back by the same route. Okay, this is called as backtracking. Once a person came to a route till its end, but he is not reaching his position. Again, he is going back to the same place, and he will try again by some other route, and he will come by this route. The route is going to stop here. Okay, no continuation from here. Again, he will come back to the same route, that is called backtracking. And then by trying and by coming back again and again, finally he will find his route to reach his item. Okay, finally he will find his route to reach his item. Okay, that is called as backtracking. Backtracking means if he will not find his correct route, okay, again by same route he will come back. That is called as backtracking. This is a labyrinth or the maze by which we can clearly understand the backtracking. By using for this type of backtracking, the stack is used. Okay, in backtracking. Backtracking means selecting from the route till its end, but he is not reaching his item or his place. Then again he will come back from the same route. That is called as backtracking. For this process, stacks are used. Come to the next application. Language processing. Language processing. Okay. What actually the language processing means? This language processing includes 3 points. The first point is space for parameters, and local variables, space for parameters and local variables is created internally using a stack. Okay, here in language, inserting any language into the stack. Under that language, parameters and for local variables. Okay, variable anything it may be and parameter anything it may be. Space for these things are provided internally using a stack. This is the first point under language processing. Next, come to the second point. The second point is compilers. See, I'm using apostrophe here. Compilers, syntax checking. For matching braces. Is implemented by using stack. Listen here. Here in second point, you need to understand the first thing is braces. What is meant by brace in computer language? I had already shown you. Okay, this type of brackets, which we will call as flower brackets, they are called as braces. And this one is called as left brace. Okay, the brace which is in the left side is called as left brace, and the brace which is in the right side is called as right brace. In English language, these can be called as flower brackets, but in computer, these are called as braces. This is a pair of brace. So this is called as braces. One is the left brace, another one is the right brace here. Compilers syntax check. Okay, compiler means compile a program. The software which is used to compile a program. It means to find the errors of a program. That software is called as compiler. Syntax check. Okay, when entering a language, it will check the syntax. Okay, for matching braces, for example, if you want to write a program, okay, think this as hash include, okay, hash include iostream.h, iostream.h. Okay, after that, what will you do? You will open a brace here. Okay, no, you will write a main program here, void main. Okay, then you will open a brace here. Okay, then you will take the initial values int a, b, and so on. Then you will write the program. After that, you will write get ch. Then finally, by brace, you will going to close a program. Right, this step you will write a program, hash include, then main file, then you open a brace, then take initial values. Okay, then after that you will going to write a program, then finally you will going to close this brace. Okay, it will check the syntax for matching braces. It will check the syntax. This is a syntax of writing program. Okay, compiler will check the syntax for matching braces. If brace is not closed, then it will give you an error. If brace is closed, when one brace is open, then one brace should be closed. Okay, if you have opened two braces, okay, then two braces has to be closed. Matching braces. Okay, compiler will check the syntax for matching braces. All these things are implemented by using stack. Matching of braces will be implemented by using stack under language processing. Okay, you have understood. Then the third thing here is recursion. Support for recursion. Support for recursion. Okay. Recursion means you will use, I will show you one thing here. After void main, you will take a small thing that is called as int a or b. You will take. After that, you will use CLR, SCR. Then you will write the programs here. Then finally, by writing get ch, you will close the brace. This means here, while writing program, you have taken initially two values. Then for this thing, you have taken two values for this thing. You will use a small program inside this program by taking braces here. By taking brace here, one is open brace, another one is closing brace. Here inside a big program, you will use a small program. Inside a big program, you will use a small program. That type of program is called as recursion. So, for this type of recursion, the stack will be used here. So, these are some of the applications of stack. Hope you have understood recursion. Recursion means using a smaller program inside a big program is called as recursion. Then next come to the next application of a stack. Next application is the fifth one is conversion of decimal number system decimal number system into binary. Conversion of decimal number system into binary. You already know the number system decimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is called as decimal number system. Converting this decimal number system into binary, that is 0 and 1. Okay, under this thing, the stack will be used for converting decimal number system into binary number system. This is decimal number system, and the next one is binary number system. And the next one is binary number system. So you have already learned in your first PUC how can we convert the decimal number system into binary number system. For this type of conversion, here the stack is used. And the next thing is to solve the sixth application is to solve Tower of Hanoi. To solve Tower of Hanoi. What this Tower of Hanoi means? Tower of Hanoi means just like it is a game. Now in Android applications, Android mobiles you are using, and you are trying to play this game. Here some poles are there. Okay. Under this some discs are placed. The first disc is the smaller disc. Okay. First one is the smaller disc. The next one is the little bigger than that. Okay. Next disc is little bigger disc. Okay. This is little bigger disc. Okay. Then one more is that is more larger disc, more bigger disc. Okay. Discs are placed like this in the poles. One is bigger, the other one is smaller, and the last one is total small. Now we need to arrange these discs in descending order or in ascending order. So if we place these discs in one pole, okay, then what will happen? In base, the big disc will be placed. In base, the big disc will be placed. After that, a smaller disc than that will be placed. Okay. Then finally, totally the complete small disc will be placed. Okay. Totally the complete small disc will be placed at last. So this type of problem will be called as Tower of Hanoi. Okay. First the larger, then little bit smaller, then finally smaller. Arranging in ascending order, smaller, bigger, bigger. Okay. This type of tower problem is called as Tower of Hanoi. For solving this type of Tower of Hanoi problem, we are using stacks, and the stack can be used for solving this Tower of Hanoi problem. Next, the next use is expression evaluating. Expression evaluating. Or evaluation and parsing syntax. And syntax parsing. Okay, expression. There are three types of expression. One is infix expression, then postfix expression, and prefix expression. Okay, the given expression is which type? Either it is infix, or it is prefix, or it is postfix. So for finding that type of expression, and also syntax parsing, I have shown you. Okay, while checking syntax, it means syntax parsing for finding the type of, for guiding or for judging the type of expressions, and for also finding the syntax of a given program. This stack is used. This is the seventh application of the stack. Next, come to the eighth application. what this application will say. This application states that conversion of infix expression to prefix and postfix expression conversion of infix expression to prefix and postfix expression. One is infix expression, the next one is prefix expression, and the last one is postfix expression. In our next class, we will going to discuss infix, postfix, and prefix expressions in detail. There you will come to know what actually these expression means. Under this type of conversion, stacks are used. The next application is rearranging railway cars. Okay. Railway you already know. It is the railway means it is a railway itself. No other meaning here. Okay. Cars means on the railway track. Okay. On the railway track, whichever the things will move, those things are called as cars. Okay. Basically, the trains will move on the railway track. Okay. Each compartment of a train is called as a car. Okay, basically you will call the compartment as bogies of a train. So that bogie will be called as car here. Railway car totally means the bogie of a train or the compartment of a train. For rearranging those railway cars or the bogies of a train or the compartments of a train, under this rearrangement, stack is used. This is one of the applications of the stack. Come, we shall see the next application, that is the 10th application of the stack. Quick sort. Under quick sort, you know the sorting, arranging the given items in ascending or descending order is called as sorting. Under this sorting, a type of sorting by name quick sort. There are many types of sorts are there. Shell sort, bubble sort, simple sort, heap sort, all these things. Under these types, quick sort is also a type of a sort. For this type of sorting, stacks are used. Next, come to the next application. Stack span problem. Stack span problem. Okay. Stack span problem means a given problem will be solved in a given span of time. That is called stack span. And for solving this type of stack span problem, here stack is also used. Then finally, the last application here is runtime memory management. Runtime memory management. Okay, while running a program, a memory space needs to be managed for storing the program. Okay, for the given program statements, to need to store, we have to do memory management while running the program. So the thing which is used to do memory management while running the program is called as runtime memory management. For this type of management, stack is used. Hope you have understood. These are the applications of stack. There are 12 applications of stack which I have discussed in today's class. Hope you have understood all the applications of a stack. In our next class, we are going to discuss regarding infix expression, prefix expression, and postfix expression. While I'm going to explain these three things, then you will come to know what actually the infix expression means, what actually the prefix, and what actually the postfix expression means. Hope you have understood all the applications of stack regarding these things. If you have any doubts, you can ask me personally. Thank you.